All right, today we're going to look at section 10.7, which is looking at the inscribed and circumscribed polygons. What does that mean? And then the relationships that we have with angles inside those polygons and some characteristics that happen when we draw those. So first off, when you have an inscribed polygon, that means that the polygon is going to be inside of the circle. And so there's a couple ways you can say that. You can say that the polygon is inscribed in the circle. You could also say that the circle is circumscribed about the polygon. So the circle goes around the polygon, or the polygon is inside of the circle. And we could say the exact same thing, just going in the opposite direction. So in this case, we would look at a polygon whose sides are tangent to the circle, which means that the polygon is outside of the circle. So the polygon is circumscribed about the circle. When you have a quadrilateral that is inscribed in the circle, we have a property that will always be true. The opposite angles must always be supplementary. So in this case, that means when we look at the opposite angles, we have angles A and C. They must be equal to 180. And then we have our other pair of opposite angles, which are angles B and D, and they must also be equal to 180. Another thing that is unique when it happens is if we say that a shape is a parallelogram inscribed in a circle, so we have both pairs of opposite sides are parallel, the only way that we can draw that is, because it's restricted within a circle, is that it has to be a rectangle. There is no other way to draw a parallelogram within a circle. So because of that, some other things must be true. So every single time when we have this, we're going to have the fact that AC and BD, not only are they the diagonals, but they must be diameters. Because if we have right angles, that hypotenuse of the right triangle has to cut the circle in half, which means it is the diameter. Another thing, since O is the center of the circle, it's also where the diagonals must intersect. And because of that, that tells us that OD, OA, OB, and OC are all radii of the circle. And then we have our right triangle knowledge with the fact that this has to be a right triangle, BCD. Then we have our right triangle properties, which means we could use the Pythagorean theorem to say that when we do a squared plus b squared, we will get our c squared. It just happens to be the diameter as well. So first example looking at this, if we first off mark the fact that ADC is 134 degrees, and then also we mark the fact that angle A is 104. And we're looking for the measure of the other angles within this quadrilateral. Well, first off, this angle B is an inscribed angle that corresponds to the arc of 134. So B is equal to half of that 134. So angle B equals 67 degrees. Then we can use the fact that opposite angles are always going to be supplementary. So B and D must equal 180 degrees. So that means angle D is equal to 113. And then our other pair of angles are supplementary, which is A and C. Therefore, angle C has to equal 76 degrees. Next example, we're looking at a regular pentagon. We need to remember that a regular pentagon means that all of the sides and angles of the pentagon are congruent. And if all the segments are congruent, that means that the corresponding arcs are also congruent. There are 5 arcs in the circle, and all 5 arcs are the same. So take our 360 and divide that by 5. And that tells us that every single arc must equal 72 degrees. So that allows me to find the measure of arc PQ, 72. And then since RST is just 2 of those, it would be 144 degrees. Next example, looking at a quad that is inscribed in the circle. Remember that a quad inscribed in the circle, the opposite angles must be supplementary. So C and E must add up to 180 degrees. And also F and D must add up to 180 degrees. We have 2 equations, 2 variables. It's a system of equations. So go ahead and pause that and solve for X and Y. When you do that, you should be able to get X equals 25 and Y equals 5. Last example, looking at trapezoid, is circumscribed around about the circle. Angle X and angle Y are right angles. XW is 16 and YZ is 7. Finding the perimeter here, we need to remember that we have tangents here. So if we don't remember if we don't know all of the measures, well, let's just call the first part there A. And if that little part from that vertex, that tangent is A, then we know that one is also A. And then we could label the other part out to WB, which means W down to this other tangent would also be B. And then same thing on the left side, to Y would be C, which means the other one would also be C. Then we could lastly mark those last 2 D and D. What I do know when I look at this is the fact that A plus B equals 16 from the top, and on the bottom, C plus D equals 7. Another thing to keep in mind is the fact that the perimeter of the entire figure has 2 A's, 2 B's, 2 C's, and 2 D's. That really just means it is 2 of the quantities of A plus B and 2 of the quantities of C plus D, which means my perimeter is going to be 46. And that is it for our 10.7 notes.